Okay, so we've identified our population of interest, Americans. We've identified our sample, 1,200, or excuse me, 1,021 of them. What I like to do is analyze the claims that are made in the headline. We'll go with this one first. Support for offshore drilling and oil exploration in Alaska reached new highs. U.S. oil drilling, you know what, now let's go with the headline first. U.S. oil drilling gains favor with Americans. That's a more broad-reaching statement. That doesn't talk about just Alaska, that talks about in general. Okay, so here's the question asked for that one. Okay, do you favor or oppose increasing offshore drilling for oil and gas in U.S. coastal areas? Pretty innocuous question. I think so. Those are the results. 60%, 37%, 3%. Okay. Here's the opening sentence. 6 in 10 Americans favor increasing offshore drilling. 6 in 10 is what percent? 60, there's 60% right there. I have a problem with that statement. No, you're saying, okay, we just told you 60%, 6 in 10. But I have a problem with saying that 6 in 10 Americans. 6 in 10 of who said they favor offshore drilling? 6 in 10 of the sample said they favor offshore drilling. That is not 6 in 10 of every American out there. We're probably going to be off a little bit from the actual number of Americans, percentage-wise, that favor it, yeah? We're probably going to be close, but we're probably going to be off a smidge. So how do you make up for the difference in the statistic, which is this, and the parameter, which is out there and we're not sure about? And the answer is actually on the screen. Boom! Some of you have seen this before. Excellent. The way you correct for a statistic is by applying what is called a margin of error on that. You stick a margin of error on a statistic. You add and subtract a number from the statistic. And that gives you a range of values between which the parameter most likely lies. So, the margin of error for this study is 4 percentage points. Up and down. It's a plus or minus. It's kind of hard to see with the image the way it is. Plus or minus 4. Which means 60 was our sample. If we subtract 4 from that, we get 56. And if we add 4, we get 64. So we don't say that 6 in 10 Americans favor offshore drilling. We say we're pretty confident that between 56 and 64% of Americans favor offshore drilling. You're not allowed to take a sample and treat it like a parameter. That's the kicker. And the news will always get this wrong, just so you know, FYI. They will always get this wrong. They will always report a statistic as if it were a parameter. Your job is to dig more deeply, find the margin of error, and apply it to the statistics. Now that margin of error also applies to these guys. And that's why I believe the opening statement, U.S. oil drilling gains favor with Americans. Because this, even if I apply a margin of error to it, it's at least 56%. The oppose is at 37%. No, it's not really 37. It's at least 33 and at most 41. So even at the biggest, 41, this is still lower than the smallest here, 56. So I do believe that more favor than oppose. Everybody follow that logic? Even with the margins on there, those don't touch each other. So this one's clearly above this one. Is that fair? Pat, go.
How do you assign the margin of error?
Nobody asked me at the break. I was waiting for questions. I was going to show you. That's what 240, a big chunk of 244 is coming up with that. I don't want to get into it in 243. It requires more inferential work and something called the central limit theorem, which we're going to deal with in this class when the time is right.
Gotcha.
There is a, no, don't be scared. You're ready for it in 10 or 11 or 12 weeks. You're totally ready for it. It's just, it's too much of a chess jump right now, a knight move, if you will, to get to it. I mean, I can show it to you. It's not going to make any sense.
Yeah, that's all right.
But yeah, for sure.
There's a way to do it, right?
Oh, we definitely will do it.
No, there's a way to
Oh
do
my
it.
God, yeah. It's
Okay.
a beautifully computational way.
Okay.
And as your sample goes up, the margin of error goes down. But rather than jump right to it right now and make this into a math class, let's just hold tight on it. But there is a way. Absolutely. I'd be more than happy to show it to you after class. Okay, next claim. Support for offshore drilling and oil exploration in Alaska reached new highs. Okay, that's this one down here. American support for oil exploration and more. Okay, new highs. New highs. Which implies that the support outweighs the not support. Or it implies that last week's support was lower than this week's support, which it wasn't, so don't worry. I'm going to look at this right here. Right now, 49% is bigger than 45, is it not? It is, right? Numerically, 45% or 49% is bigger than 45. But 49% of whom? Of the sample said, yes, we should drill in ANWR. And 45% of the sample said we should not drill in ANWR. The no opinion was at 6%. We can ignore that for right now. Okay. So 49 is bigger than 45 in the sample. How about the population? Can we say in the population more say yes, drill in ANWR than say no, don't drill in ANWR?
No.
I'm seeing some head shaking no this time. Tell me why. Joe, tell me why.
Because the margin of error.
Put the margin of error on there. You have to. You are obliged to. This is not 49. It might be as low as,
45.
and it might be as high as, boom. So what would we say, 45 to 53? Yeah? This might be as low as 41 or as high as,
49.
so you see what happens there? Where the previous one looked like this one does this, which means we can't tell if one is above the other one. Because I teach it as the fishies in the tank. The parameter you're studying is in there somewhere, but you don't know where. It's not more likely closer to the middle. It could be anywhere in that range. So it might actually be that in the population, this is bigger than this. You just got a random fluke in your sample. For example, a sample where I drew all three of you. It happens. It's just a random fluke. Does that make sense? Always beg for margins of error. Go find them. In Gallup polls, just so you know, they're always in the bottom. And they're usually in 4.5. Just so you know. On the news, you will not see them on the news. You will not see them on the news. But you can find them. Just go Google search for them. You can find them. Fair enough? They're crucial. They really are crucial because they're your way of bridging the gap between your statistic and the parameter you're studying. Which you're never going to know, correct? You're never going to know the parameter. It's out there floating around unknown. Your statistic is the only view that you have. So you have to widen your view to make sure that you've most likely caught it. Believable? Oh, Guy, go ahead.
Who determines the 95% confidence?
Great question. It's tied to the 4% margin of error. Guy asked, who determines the 95% confidence? Industry has determined it. It's the most common confidence level used. And it's tied directly to the margin of error of 4%. Here's the deal. Here's the deal. You could be wrong, yes, in your sample. The percentage of people that approve of drilling in ANWR might very well be something like 20%. And you just randomly sampled a group that said half said yes, half said no. It's possible. You got a goofy variant sample, an outlier sample, the 619 area code. I could have drawn you, Linda, and therefore gotten the wrong idea of who's out in the world. I was just told by a 244 student there's an entire branch of anthropology devoted to studying the history of this one particular locale of human that's based off of one skull measurement. One. Every theory about this one people, this one indigenous ancient people, is based off of one skull sample. What if that guy was the weirdo? We've got the wrong idea. Right? We've got the wrong idea. It's like an alien coming in and see my punk rock friends. Oh my God, humans, they have blue hair. Right? That's a weird outlier result, but it could have happened to us. What 95% confidence says is 95% of the time it won't. 95% of the time we're going to be close to the true value, which means we're going to miss it 1 in 20 times. Which is acceptable because of two kinds of error, which is also tight. I'm going to stop there if you don't mind. It's too much 244 in that question. 95% is standard though. Anybody ever talk about a p-value of 5% in sociology or psychology? It's all tied back to that as well. But it's definitely getting in the 244 land. You just worry about the margin of error and trust that the confidence is set correctly. Because it is. It is. Cool? Great questions. Great questions. All right. Let's back up. That was a lot. A lot of good stuff. We're going to talk about data presentation. We just saw some an incorrect conclusion based on data. At least I call it incorrect. Gallup will argue that you should enter the margin of error, you make the conclusion yourself. Good for them, because now we can. But here's some raw data. Here's some raw data. And we want to present this to our superiors in a way that's meaningful to them. So we're trying to keep track of products produced by a small business. I'm not interested in statistics or parameters right now, just how to put the data out there to be visibly seen. It's not always about an average, it's not always about a standard deviation. Sometimes it's simply about just, let's look at the data and see what it shows us. We did this in 244 quite a bit yesterday. So here's some numbers. I call this raw data. Whenever you're given individual data points, I just refer to it as raw data, and it's fantastic. The problem is you very rarely don't get it. Very rarely this is hidden within some kind of a construct. Why is having the raw data in front of you wonderful? Why is it great? It gives you something to work with, exactly. It gives you something to work with. Why else is having the raw data great?
There's no bias in it.
There really isn't, right? There's not a whole lot of bias, especially if it's randomly scattered like this is. What's the downside of having the raw data like this? What's the downside of this?
It's only up to those 20 people.
Well, I suppose there only are 20 people. Good. But let's say there were 2,000 people. We've got a group of 2,000. That could be a pain in the butt. It's not organized at all. What's the biggest one? What's the biggest data point? 39? What's the smallest?
10.
Good. I'm watching your guys' eyes when I ask those questions. You're scanning like this. Because you have to go through it all. Now imagine there were 10 times as many.
Screw that.
Or, screw that. Good. Good, Nick. Thank you. Good answer. Next slide, please. Right. So here's one way of dealing with it. This is called a distribution. I love these. These are wonderful. We're going to use them all the time in this class. You take raw data and you fit it into some kind of an organized, orderly construct, just like Di said. Now, look what I've done here. I've chosen to break this up into groups of 3. So this column, think about it like an XY chart in algebra class. Here's how many products are made, and this is the frequency of occurrence of that. See if you can make sense of this. Number of products, 10 to 12. Why is there a 1 here?
Because there's only 110.
Because there is 1 10 right there. Are there any 11s?
No.
Are there any 12s? So there is 1 data point between 10 and 12. That's it. 1 data point between 10 and 12. 13 to 15, I see a 2. Why is there a 2? Because there's a 14,
2 data points.
and there are 2 data points between 13 and 15 inclusive. Beautiful. Why is this good? Why is this better than raw data, I should say? What is your data now?
You can do the 2,000 samples.
Exactly. If you had 2,000 or 200,000, this wouldn't get any bigger or any smaller. What would change would be the numbers in the column. Excel does this automatically. We'll teach you how to do that in Excel in this class. What's bad about it? Or what's potentially bad about it? Or I shouldn't say bad. It's not bad. What's not quite as good as having the raw data? Because in general, you're not going to have this and this. You can still see it on my butt, can't you? Okay, so you usually just get this. So tell me wait, this is one of my Carly's, right? Yes.
Yeah. Well, you're not going to know, like, say for the 10 to 12, you won't know the exact number.
Exactly. We know, for example, there are 5 19s to 21s, but how many are 19s? How many are 20s? How many are 21s? The best part of that, Carly, thank you, perfect, is we can get around that via something called the law of large numbers we'll deal with on Tuesday, I think. We actually start analyzing some numbers of our own that we collect. So I like it. I like it because that is the big problem, is that we lose the exactness of this. But we can deal with it being creative and using this thing called a law of large numbers and law of averages. Cool? Make sense? All right, now that's great. Why is this even better?
You can visually see it.
See, this is no different than this. This is called a histogram, or a frequency histogram. I can call it a histogram. This is the same as this. Make sure you can buy why this is the same as that. Make sure you see it. You see all those numbers, the frequency numbers up there represented in the bottom image? Yes, hopefully. And like I said, you guys are going to have this posted. You'll have this posted. You don't have to write all this stuff down if you don't want to. Why is this better? Potentially better? Or those of you that think this is better, why is this better than this? I shouldn't say why is it better. It might not be better for you. You might like this better. For those of you that think this is better, why is it better than this? Pat, go ahead.
It's more visual.
More visual, you get a dimension, you don't get up there, you get a second dimension. This really is a 2-dimensional construct, x and y. And now you've got x and y, so it ties into kind of like your mathy backgrounds, which is good. I like that.
It's faster to get the information.
Oh, I wasn't thinking about that, but that's true. You might be able to process more quickly the differences. Why else? I love that. I wasn't thinking about that, Di. Why else?
I think anyone can understand the bottom without too much.
That's interesting, Joe. I bet you're right. I bet he's right. He said, I bet anybody can understand the bottom one more than the top one, which is amazing because they say the exact same thing, but I bet you we're just conditioned to kind of seeing things this way, and therefore it just links up with it. Be careful when you're making these in Excel. Make sure you give things like scale so that you don't mislead intentionally. But good, yeah, good. Anything else? Here's why I like it. This is, oh no, go, Carly, go.
Is the scale appropriate on this? Like 10 to 12? Is that the same? Is the distance
Love
the
it.
same for the?
Love it. Carly says, is this subdivision of the range appropriate? There's no definition for appropriate or inappropriate, my friend. You could make half as many bars, but then each bar would be twice as wide. If that makes sense. So the span is about 30, yes? From 10 to 40, I'm gonna call that 40 if it's okay with you. So 10 to 40 is about 30 wide. These are all 3 wide. So there's 10 of them. 10 times 3 is 30, right? We could make them 6 wide, and then you'd have 5 of them instead of 10 of them.
I just mean the x-axis and the y-axis are the numbers, like the value 10 to 12 is 3.
Yes.
And is that the same distance, is it the same scale used on the x and the y-axis?
Oh, well, no, because if this is 6, this is only about 18. I see what you're saying. That doesn't bother me as much, because all that changes is the width of the bar. Although some would argue that making the bars more narrow or more wide might psychologically guide someone. I haven't seen anything that indicates that to me. The problem I would have, Carly, is augmenting this in any way. Like not starting this at 0 would bother me. But I like your point. I mean, you can make it 1-to-1. It just gets tricky for a couple reasons. One of which is it might be cumbersome. If I wanted to keep this as 6, I'd have to have the bar graph going halfway across any 2 screens. And I could bring it back in here, but then this guy shrinks down to this. So 1-to-1 this way isn't as crucial as accurate this way. Does that answer your question? I misunderstood it at first, thank you. But she asked a good question, or she implied a good question maybe, in how do you pick how many bars are in your histogram? I made it at 10, right? Why not 5? Why not 4? Why not 2? Well, I think 2 would be kind of silly, because then you lose any kind of fine-tuning. But this is great because you see where a big chunk of data lies. If you make too few bars, those chunks of data might disappear. If you make too many bars, those big chunks of data might disappear. It becomes more of an art form, and you won't be responsible for mastering that art before you leave this class, because it takes longer than 10 weeks. So for now, I'll tell you how many bars to make. And we'll experiment as we're in class. So we'll mess with the TIs a lot, but that's where the TIs really shine, you know, to do this.
Isn't that called ranging?
Probably could be.
Well, when you decide from 10 to 12 instead of 10 to...
Oh, this particular, what the hell is that called? A class? A class width? I think it's called a class width. It's got a term, which I... Probably. Yes, I know we used it in 105. Sometimes we used a class width of 1 in 105, like trial 0, trial 1, trial 2, trial 3. And I mean, we can fluctuate quite a bit here. We will. I'd like to, actually. Good questions. Ask me more. Do you have more? We can do wonderful stuff with this, and we'll start doing it on Tuesday, I promise. But right now, just realize that's what we call a histogram.
And why do you like it?
Why do I like it? I like it because it shows you this with a second dimension. And you see how that's 5 and that's 1? This is actually 5 times as big as that. Whereas up here, 5 and 1, your eyes might gloss right over that and not catch the fact that it's 5 times bigger. Because the number 5 is not 5 times as wide as the number 1. You see what I'm saying? You get it here, though. You get the scale. You also get the zeros. The zeros are missing. You might gloss right over those as well. So I like it because you get that actual numerical scale, which is why it's so important to scale the Y properly. Otherwise, you might look at like it's more than 5 times or less than 5 times. We saw that in the broadside piece on Tuesday. Yes, you're nodding. Good. Fair? Excellent. All right. Now, there's a few other ones. That are histogram-like. There's a whole buttload of these. Buttloads of mathematical terms, just so you know. In your book. We'll get them as we go. But I want to focus only on the histogrammy types right now. The first one's called a Pareto diagram. And rather than just give you a definition, I want to make one right now with you guys. So here's what I want you to do. I want to ask you a math question. Actually, I want to ask you a buttload of math questions. And then I want to ask you a non-math question. You won't need pencils for this. And don't say anything verbally. I'm going to ask you a bunch of rapid-fire arithmetic questions. I want you to answer them in your head. And then at the end of that, I'm going to ask you a non-math question. And that's what I want you to, you might want to write that down or just remember what you answer in your head. Answer all this in your head, because I want everybody to kind of do their own little random sample. Okay, you ready? Okay, close your eyes if it helps. Bunch of arithmetic questions, answer in your head, and then a non-math question, answer in your head. Here we go. 3 plus 3, 4 plus 2, 1 plus 5, 2 plus 4, 0 plus 6, 5 plus 1, 3 plus 3, 2 plus 4, 1 plus 5. Think of a vegetable? Man, David. I'm gonna swing, Haley, would you mind swinging that camera over this way? We're gonna put it on this board. Thank you so much. Let's get a Pareto diagram. Okay, so what we're gonna do, you know what, actually, I got a better idea. Let me pause and restart, because this video is probably getting too long. Let's do this. Thank you for